Last night we did a stream about DLL hijacking and what indicator of compromise it is behind. We started by analyzing step by step our previous shellcode runner from my previous video, as well as some snippets from my offensive C++ repository. We then combined the pieces and performed fully working DLL hijacking scenario attacking DVTA application. This is the full stream, stay tuned, have fun, and drop your questions below. Alright. Now I was talking without putting up my microphone, but now I do. So, hi everyone, and I'm so happy to be here. That's my first time of streaming in both platforms simultaneously. So I'm doing that on Twitch and on YouTube on the same time. And I'm gonna do my best to take and track both of the chats. So if you guys experience anything like a disruption or anything else, just let me know. Yeah, so I have both of the chats, and let me just verify that everything on YouTube is going good. Or anything else, just let me know. Yeah, alright, it looks nice. Now, I hope that the music isn't too loud. If that's the case, just let me know to make sure it's a little bit lower. Yeah, I'm waiting for your feedback, guys. Now, let me jump right into the point. Now, what we're gonna do now is perform first test and analyze the thing from the my previous video, which you already might have seen. If you didn't see it already, I can send it to you right over here. So I'm gonna share and copy the link and paste it here. Yeah, there it is. Now in that video what we did is we generated what's so-called shellcode runner in C++. Now the idea of today's stream is to pretty much do that, but make it through DLL and perform DLL hijacking. Now I want to first go ahead and analyze the code and exactly what it does to process. So yeah, let's just do that. So I'm gonna open up my commando. In the directory, I'm gonna open up a new Visual Studio project and we're gonna start right into it. So I'm gonna go ahead and create new project and console app and call it like stream. Now click browse and do desktop stream here. Alright. Now I'm gonna navigate to the thing, because if you didn't know, I created the offensive C++ directory, and there I'm gonna upload different kind of code snippets regarding of C and C++. Not all of them are mine, of course. I'm collecting snippets that I found on the wild, and I think that's a nice place and nice thing to have, of different kind of snippets collected together. Because when you try to compile and work out something, it's just easier if everything is structured in one matter, in one repository. Yeah. So the repository is here. I'm gonna link that in the chat, like that. So you can go and analyze and also make sure if you have and willing to contribute. That's an open source project, meaning that all of you guys can just contribute. Yeah. Now that's our default function there, default program. I'm gonna delete that. I'm gonna navigate to the repository. I'm gonna actually share my screen. It's right here. And now let's go to shellcode execution, because we did that. And by the way, I found an amazing repo regarding of enormous amount of ways to execute the shellcode. For instance, that one here. Oh, I think something happened with YouTube. Is it the case? Nope, it's not. All right. Yeah, alright, we're good. Now, all these ways, all these, I can say files, are a way for us to execute shellcode. So, a lot of things there. Now, for instance, not all these functions can be traced back and parsed into process injections, meaning that with not all of them we can inject shellcode from different process, but with some we can. Now, the idea about today's video in stream is not that, but to make DLL hijacking. Now, what we did in the previous video was that file map thing here, And if you see into the file map, that's pretty much the syntax. Now the file map is in a nutshell shared object, meaning that we can access different kind of file mappings from different processes, which can be handy and can be used in let's say twisted form of process injection. I didn't research that much, but I think we can do that here if we have the time, of course. So give me just a second, please. Yeah, all right. So I'm gonna copy that and move to my command here and just paste it because why not? Let's remove the comments, and there we are. Now what's gonna happen now is what shellcode we put here is gonna get executed after we run the program. Now let's go ahead and generate a simple shellcode. Now I'm gonna do simple reverse shell TCP, and my idea is to trace back using process hacker how different shellcode behaves and what IOCs they're placing behind. So I'm gonna do tmux first, cd desktop, mkdir stream, cd stream, and let's do msf venom, and there is the payload. Now that's the reverse stageless payload, and stageless reverse shell is not that huge, it's like 460 bytes, so we don't need to worry about that. Now format C and shellcodes being shellcode.c. Now I'm gonna host a simple listener here so we can cache the shell. Alright, the file is being written. I can cut shellcode.c and copy it to my clipboard with Excel, and I can paste it here. Alright, that looks nice. And now I'm not sure why that's behaving like that. If I try to compile, it succeeds, but I'm not sure why the IDE is saying it fails. Never mind, it should be nice. So let me just compile that as x64 and release because we want that. We won't use that. Alright, and now I'm gonna open up my terminal there, the CMDR, go there and do stream.exe. Now if I run that, obviously I should receive a shell, right? Now I can do whomi, ipconfig, and all the stuff, right? That's nice. To get in more context about how that really works, make sure to click the video I just sent and you should be fine. Now here I want to see what's really happening and how can we really trace something, right? Because that's important. Now I can do process hacker, the second version, and let's trace our process which is called stream. I can't find that so far. Should be somewhere here. Yeah, there we are. So it spawned as a so when I use CMDR, it uses COM-EMU64, so it can emulate different kind of terminal emulators there. Now it spawns PowerShell because I'm using a native PowerShell here, and from here I use stream.exe, so it spawned stream.exe as a subprocess of the PowerShell.exe, right? And then the stream.exe seems to have a subprocess of cmd.exe, so that's most likely our reverse shell callback. So I can do a bunch of commands, and we can do if we have some network traffic going on. So where was the network tab? Network, let's do stream.exe, and yeah, we can see that we have established connection. Connection. We have the local socket, yeah, which is that one. Then we have the remote IP, which is that one. Then we have the remote port, which is that one. So it's really bad because, as you can see, we are super visible to anything, right? So how do we bypass that? Is we genuinely want to use process injection. That way, for instance, if we migrate into some service like SVC hosts or anything else that communicates to a that by definition have some network connection, as like that one, then we can segment that and kind of obfuscate our network activity. But in that case, we don't really care about that. So yeah. Now let me just go back here, and if I close that, if I do terminate, our shell should be gone. Yeah, it is. Now, that's the process that was spawned from the shell. Now, what I want to do is to make the same thing using DLL, but before that I want to test different kind of payloads to see what process they contain and they create. Because in that example we found out that the Windows stageless reverse TCP is creating cmd.txt subprocess, and I want to see how Meterpreter is behaving about that. So let's go here, generate a new one, and do Meterpreter. Alright, and now we need to do it staged, because that way it's be super huge. How are you guys doing? I'm waiting your feedback about the streaming platforms. Can you hear me well in both YouTube and Twitch? If so, I'd be super happy about that. Alright. Alright, now the shellcode is kind of bigger. Now we have like 510 bytes, so let's just copy that again. Let's move it to here. Alright, let's compile. And now we need to set up a Metasploit listener. So let me just go back here, do sudo msf console, and that should be fine. And by the way, I want to analyze if we can see the traffic with Wireshark, because we don't review certificate. So by definition, we should be able to. Alright, and do stream.exe. Come on, do something. Did I compile that? That's strange. Alright, let's compile again. It was compiled. So run that. Oh, session died. It's not valid and will be closed. Maybe we used... Yeah, we used stageless payload there. So set payload is gonna be Windows x64 Meterpreter reverse TCP, show options. Yeah, that looks nice. Let's do exploit and then run that. Alright, now we're talking, and we have shell now. Now let's do the very same thing with Process Explorer, but that case we don't see a shell. Now we have the Meterpreter callback, but no cmd.exe or console host is being present, which is nice, obviously. So we skipped one IOC just by changing our shell environment. Now, of course, I can do a bunch of commands here, or what was that? PS. I want to see if I run PS or something that I'm gonna see a pop-up here, but that's not the case. Now, what I want to do is, of course, if we go to network and stream, we can again see the IP and the port, but we just got rid of one IOC. But what's gonna happen if I do shell? Bam! Immediately we can see it stream.exe starting cmd.exe, which is starting conhost by its own, meaning that spawning shells is a huge IOC and should be evaded at all costs. So yeah, that's a huge IOC. When I was testing my AV evasion things against different AV vendors, I stumbled across I'm getting successful Meterpreter shell. Yeah, I appreciate the feedback about the Twitch stream. Now, when I was doing, as I said, my evasion techniques against various AVs, I was getting full Meterpreter, but as soon as I'm getting shell, my session is being flagged up and of course killed. So just by doing that, it's not a good practice, and I can either suggest you guys to use a C2 that has a more stealth way of doing commands. That, for example, can be silver, and we can test that also. So far, I'm gonna do. Give me a second, please. Yeah, all right. Now the show should be gone. Yeah, it is. Now I'm gonna do migrate. I can do PS and then do SVC host. Let's find where that is. That should be fine. No, that's conhost. I want something that's under my user's environment, so I can successfully inject into that. Because if you try to inject into process with higher integrity of different user, most likely it's gonna fail. So that's why I'm searching for something, for example, that one, which is a perfect candidate. So we have 4512, migrate 4512, and not sure what that is. But as we can see, that stream disappeared. When you see that red flash, meaning that the process is dying or something else is happening, most likely dying. Now, what happened is that we migrated into SVC host, so most likely we can find that stream.exe under SVC host, and most likely that's the one. No, it's not that. It was what was that? 4512. Let's filter that by PID. 4512. There we are. And now, what we can see. Stupid dog, sorry about that. What we can see is that the IOC is kind of mitigated, because when we started to the whole executable, we can see it generated a new process. It started a new process, which is normal, of course, based on the code. Then if I do shell, it starts sub-process with the CMD, which is a huge IOC. All the vendors and EDRs are scanning for that. The interesting thing happened when we moved and migrated into SVC host, and we observed that the process completely disappeared. So now everything that happens is going through the context of SVC host without leaving potential IOCs. Now if we go to network, because that can be interesting, we can see that the previous command just disappeared. Now that one here is supposed to be again online, which I'm not sure why. Maybe I need to refresh. Nope, it's still here. I'm not sure why that is. We can analyze that. But I want to search for the SVC hosting. Do we have connection from SVC host to my IP here? It doesn't look like it. So I'm not sure why that happens, by the way. Maybe we didn't migrate fully. I'm not sure. If I do get pit, we see we are 4512. On the... Do we have the pits here? No, that's support, state, owner. Can we do network from here? So no, we can't. So I wonder what's gonna happen if we close that. So we have a running instance of stream.exe, which should not be that, but it is. So I'm gonna close that in 3, 2, 1. Go to process. Oh, we can't. So it migrated, but most likely the process hacker did not auto refresh. I'm not sure why that happened, by the way. Let's do process hacker again and do network and find our IP, and there it is. So now we have unknown process, which again can be an IOC, right? Because we have an unknown process, but why that appears? Oh, I know why. So what happens is that when a process dies, alright, so when a sub-process dies, the parent one can still hold data. And I think that when the connection is being established initially, that's been written in the Windows database, like in the pros table and so on. And now we can just see that even though we migrated. Now, since we migrated, we can't see the source of the process because it's unknown, but we can see the previous PID of the initial connection. So that was the PID of the stream.exe. I'm not sure why it's not supposed to be on SVC host, to be sure. If you guys know, just drop it on the chat. I'm really not sure. Now what I want to see is if I do shell here, what's gonna happen. Now let's go to process 4 or 5. Where was our one? What was the process, the PID, by the way? 4 5 1 2. Yeah, there we are. And now we don't see the shell. Now what happens, what turned out to be, is that after migrating, the shell IOC is not that huge and not that problematic. So just by using pros migration, we can get like rid of huge IOCs that can spoil us in some way. Because now we can do shell, but as we can see, we didn't spawn the shell from the SVC host, which is that. Where was that? 5 4 4 5. Yeah, that one. We did not spawn that as subprocess, but most likely it's the individual one. And I'm not sure why, but I think that's the one. So let's go to a network and let's see if we have another connection to that IP. Because if we have, that's gonna be the shell, right? In that case, we don't. Whoa. So you say that, it turned out to be, if we do a simple process injection or migration, we save a lot of IOCs, which is super important. Wow. Yeah. Just for the fun, I want to close that. So let's do terminate. Yeah, it was the same one. I got it from the one shot from the first try. Yeah. So that's a nice one, because what happens is that it spawns a separate process, not a sub-process. So if that one is being killed, your session's not gonna die. But without us doing process injection, the session is doomed to death after we get caught by the shell thing. So that's a nice lesson, guys. Always do process injection. Always. And if you're wondering how, I have code snippets on my repository. And of course, I'm gonna do video about that. So now the next idea would be to translate all of that into a DLL and perform DLL hijacking. Right. So I'm gonna leave that open, by the way. And we can observe that the terminal is being freed because we migrated, right? Because after I spawned the initial interpreter, the terminal was hanged because it was locked by the shell itself, right? Now when I did migrate, then it moved into different process, and so far it freed the previous one, and we can start typing commands while I have the session. Super cool. And by the way, I need to just make that a little bit more, yeah, like that. Super hard. So I think it's nice on your side that do not affect the OBS, but yeah, tell me if you have any disruptions. Now let's do it in a DLL format. To do a DLL, we can do file. Let me just copy the code, because we can use the same code after all. Then we're gonna do file, new project, and in that case, we wanna do Windows desktop, and then do DLL. Now I'm gonna call that DLL1, and by the way, I can include the project here, so I can do new, add project, and the same thing, DLL1, and browse. All right. Oh my god, that dog is so annoying. Yeah. So that's the DLL format. Now let me just give you a little bit of a context about DLLs and EXEs, so we can discuss something. Now on the EXE, we observe that we have a main function there. That main function is the entry point of the program, so when the program is being run, the Windows knows from where to start. And After we start from the main, it's gonna execute that. If it's gonna see any function, it's gonna loop to the function, get back, and so on. So that's the main idea. You have main, and the code from the main is gonna be executed first. Now when it comes to DLL, we have what's so-called DLL main. And we have a bunch of ways of executing things. For instance, the process attach speaks to its name. So when that attached process, because overall DLLs are meant for that, meaning that Windows works with DLL natively, meaning that you have a bunch of codes and libraries and structures and everything that can be defined in a bunch of DLLs, and Windows can share that between processes, right? Because sometimes they need to use the same APIs. Let's say two processes can use the same APIs, or two processes can use the same functions and the same code, the same structure, doesn't matter. That's the form of Windows of sharing files. And the DLL main contains of many functions of executing a code, and one of the most important for us is that DLL process attach. Now here we can do, for example, message box A, and do like, what was the syntax? No, and then do test, and then do test2, and then do mb OK. And I think we should include windows.h. I'm not 100% sure, but let me just compile without it. Alright, it was compiled, so we didn't need to include that. And in the same directory now, I can see DLL1.dll. So it's compiled in the same directory as the exe. Now I can do run DLL32.exe and specify the DLL1.dll and do DLL main. Yeah. And there we are, we have the test. Sweet. Alright. Now we have an error on the second one, because I think we need to explicitly export the main function. So let's just do that. I think I have a code snippet for that as well. So I'm gonna do here. Where was that? No, it's not that. Yeah, there it is. So I think that we can do something like that one. Expose a different, oh, not that. Come on, don't tell me my keyboard is being broken now. Oh, there we are. So we can export a function, and we define it's a C-type function. And we can call that, for example, my DLL main. And for instance, we can paste the same message box here and just change the values for, like, let's say 3 and 4. Compile that and return 0. Alright. Now, when we're doing run DLL, we need to specify that my DLL main. So we can do my DLL main. And now observe what happens. The first time we attach the DLL, we used and read the DLL, the attach method is being used. So the DLL main is being used. That one here. And now if I click OK, now the second one is being used, but now we did not error it out because we exported the main function for the DLL, which is huge. Because obviously, if we did send some DLL or did some DLL hijacking and we see an error, that's suspicious, right? That's an IOC in any form. Now, by exporting the DLL main, now we're just fine. So just keep in mind that should get executed as well, because as soon as we attach the DLL to the process, that thing is gonna execute it. Yeah, alright. So the good thing is that we can easily translate our previous code to that here. For instance, we can do here, we can copy the buffer, we can copy the libraries we need, then go to here, do it like that. Yeah, exactly. And just literally copy and paste the code. Without the message box, we don't need to read that. Alright, now that should be fine. I'm gonna compile that. I'm gonna background my session and start a new one. So I'm gonna do bg and do exploit. And here run the same command. Of course, now we are simulating the DLLs being executed with run DLL, but in real case or in more practical case, we want to do DLL hijacking or DLL sideloading to force some binary in most, let's say, in the nicest case, some signed binary from Microsoft to execute the DLL, right? Now, let's just test that. Run test, no second message box, but session, nice. So that's how we generate the DLL. Now I want to showcase something. I want to go to anti-scan me and test both of the files to verify that most of the AV signature vendors are not scanning DLLs as much as they do exist. So we can do anti-scan me. We can first browse the desktop stream x64 release. First, let's go the stream.exe, and we can expect a lot of detection rate because we use non-encrypted Metasploit shellcode. By the way, that's not that huge. We have like 9 out of 26 with a raw Metasploit payload, which is huge. All right, never mind. Now we have 9 out of 26, so now let's scan the DLL. Do it like that, scan file. 8 out of 26. So same code, one AV is failing to detect that. Now, of course, as I said, that's based on the signature itself because I'm using non-encrypted Meterpreter payload. In case I'm using, let's say, staging of the shellcode or encrypted one or staging encrypted shellcode, that detection rate is gonna be super low, close to 0 or even 0. Yeah, but in that case, we have like 8 out of 26. So let's compare and see exactly which AV failed. So here we have, the Fortinet one. So yeah, the Fortinet fails to detect the DLL. All right. Now let's move into the DLL hijacking and demonstrate that. So I'm gonna use what's so-called damn vulnerable tick client, which is something like a damn vulnerable web app, but for a tick client, meaning that it's a Windows-based application designed for testing multiple vulnerabilities. One of them is being DLL hijacking, so let's try that. I'm gonna copy the code and open that. I think I need to compile it myself, right? Yeah, I do. So let's do it like that, and then do extract stream, and here let's do DVTA. Yeah, exactly. All right. Now let's go back and compile that. So DVTA, open the solution file, and is that everything? Yeah, it is. Should be. All right. Can this compile just right off the bat? Please let that be the case. Let's do x64. All right. And close, compile, cross fingers. Woohoo! Nice. All right. So under, I believe, DVTA, we can see bin, we can see x64 release. There we are. All right. There it is. The app. Now, of course, if we want to do DLL hijacking, we need to first identify one. That's been done by, most oftenly, I do it with the process procmon, that one here from sysinternals. I'm gonna get rid of my previous ones. Actually, I need that, but let's do it from scratch. So I'm gonna, as the default one, I can do filter, of course. I can do filter. Then I can do result. Where was that? To contain, because I always write contain, because if I mistype something or I do not need to type the full name of the thing, it has like more results and I have less fail proving. So the result contains not found. All right, then I want to path to contain DLL, or actually .dll. All right, so and the process name to contain DVTA. The main reason for that is I'm not sure if I need to say dvta.exe or just dvta, but yeah, never mind. So let me just open up the binary again, and we have a bunch of stuff. Now all these things you see here are not found, meaning that it tries to look for a different kind of DLLs, but it was not able to find it there, and on all the places here. Now we can, for instance, see that we can do DLLs named. If we name a DLL the exact same way and place that DLL into the exact same folder, we can force the application to load our code into loading our DLL main. Sweet, right? Now let's see what's gonna happen and what function is gonna get executed after we hijack the DLL and place it there. So I'm gonna minimize that since we have already compiled. Just gonna open a new pane and do desktop, stream, x64, release, and copy that one here. I want to copy that into here and name that as shown here to be cryptsp. Just like that. cryptsp.dll. Alright, and let's just restart the application. So, oh yeah, I'm here. Run that. And we have the test, but can we get the thing executed? So I'm just gonna set up a new listener, do bg, and do exploit, click overwrite, and no shell. Now you may ask why, because our custom function was indeed custom. So we need to either call it from here, or we need to modify the DLL to execute that specific function from startup. Now, of course, the easiest idea would be to just call it here, so I can do like my DLL main, and do like int I equals to or s equals to that. And actually, I do not need that. Compile that, and we need to define it. I'm not sure if I'm doing that the right way. Nope. Initialization of res is skipping by the case label, so in that case I'm gonna remove that, and instead of that I'm gonna just copy the code. So just like that, place it here, and after the message box that thing is gonna get executed. Alright, I wonder what's gonna happen if I put that into a different function, so we can, without external C and something. Yeah, we're gonna test that. So I'm gonna, because by leaving all of your malicious code into the DLL main, that's against a huge IOC, but let's see how that works. Compile that, and let's replace the file again. Oh, come on. What happened now? Oh, we need the break. Yeah. Oh, come on. Let's do it like that. Let's remove that and make a new function, which is being void and exec and no arguments there. Paste that and define it here. Define its signature. Alright. Now let's do exec. Alright. And now the file is chained because we have a session right now. So we need to either migrate or close the shell there. So let's see how that works on Process Hacker. Can we trace that here? We have the run DLL and nothing else, but let's go on the network, run DLL. We can see again it has established connection. Alright, so run DLL, terminate that, and now the session should die. Yeah, it did. And now we can compile. Alright, now it worked. So we store that into a different function and it should be fine. So I'm gonna go to here, remove that. All right, and copy the next one. Oh, come on. All right, just delete it from here, just to make sure no errors are there. And let's set up a listener now. I think I have it already. So let's do, just open the app, test, click all right, and bam, we have a shell there. We have session, but again, no app is being spawned. Should we do DLL proxying, guys? I, to be honest, didn't do that so far. Do you want to see that, chat? And come on, why is my session not there? I'm trying to think of a reason why it's dying. Do we have DVTA? We have. Let's terminate that. Actually, let's do it like that. All right. It executed the code because I'm getting a callback into downloading the stager, but my session is not completing. That's super strange. I'm really not sure why that's happening. What's gonna happen if I do it with the different shellcode, like shell reverse TCP? Let's close that and set up an NCAT listener. Compile that now. Yeah, all right. DVTA, close that. Yeah, we didn't really have shell. And I'm not really sure why. If we do the same thing with the run DLL, it's supposed to work. So let's do DLL. Alright, and do DLL main. Alright. Oh, I didn't set up a listener, so dumb. Always doing that. Yeah, we have a shell now. But why it's not working with the DLL hijacking thing? I'm really not sure. So we're gonna debug that. We have something to debug now. I hope you like debugging because that's what we're gonna do. Give me just a second, guys. I think something's wrong with my YouTube stream. It's not started. The whole time I was not streaming on YouTube. Yeah, I need to get more experience about that. Oh my god, sorry about that. How do I start that thing? The hell? That's so fucked up. Oh my god, I have to click go live. Sorry about that, guys. The one you joining from YouTube. I just did that. I just went live, and the whole time I was going live and I was explaining stuff from Twitch, but I forgot to click go live on YouTube because, you know, that's my first time going live on YouTube, and I'm going live from two different places. So apologize about that, but the first yeah, the first minutes is gonna be uploaded on YouTube either way, so you can watch it. So sorry about the delay. Never mind. So we're gonna continue with that. What we want is to debug that so our DLL is executing the function and getting a shell. Now I'm not sure why it's not doing that. So the message box we know is getting executed for sure. Now what's gonna happen again if I do that? Just for the fun. We can't just do that. We need a function there. Alright, that's acceptable. Now, do we need to make the DLL under C#, because that was C# binary there? I'm really not sure. Whoa, that can be a reason about that. What do you guys think in the chat? Alright, let's see. Let's ask Google, why not? Can I execute C++ DLL from hijacking C# app? No, it's not that. It's not that as well. It's not that. I mean, that can be the reason why that's not working now. Do you guys have idea if a binary is written in C++, can I hijack a DLL written in C++? Maybe that's the reason why it's not working, or maybe I'm doing something super wrong with the DLL. So let's see, we have defined the function which is exec, which is doing that, you know, in the shellcode pretty much. Maybe, can I do that to see where it stops? So I can do test one. I'm gonna remove that, or just comment it out. Let's debug it the old-fashioned way. So here, let's do test 2. Let's do test 3. Yeah, sorry about that, but that's how we debugged in the old time style. And test 5. Compile that. And let's try to run it again to see where it fails. So I'm gonna copy that to here. I'm gonna remove that, paste it here. Grep test p.dll and run the app. Test 1, test 2, test 3, test 4, test 5 is not executed, and there's a reason for it to not be oh. Do it needs more time to process? The fuck is going on here? If I do exit, the app should start now. Or not. Where is the DVTA? It's dead. Alright. So let me just double check if I'm not going crazy. Run the app. Test 1, 3, 4, no 5. We have shell. Don't tell me it needs time for processing that. So if I do that, and nope, not that. Not that, but that. If I, by the way, that's gonna be easier and better. I'm gonna compile again. Don't tell me that's the reason. For real. Oh, it's not that. Alright. Alright, run that again. Oh, half shell. Alright, so it was not that. I'm not sure what's the difference now. Your hijacked program is probably dying because you're not exporting the function it is working for it. It finds the DLL. Yeah, the program is dying for that, but my DLL was dying as well. My shell was dying. So I was not sure why, but I'm still not sure why it works now. For real. Like I didn't do anything different besides... Yeah, me too. What the fuck there? Don't tell me it's that message box here. Come on, don't... That's impossible. I mean, it's really impossible there. And let's do exit now. The application is dying because we need to do DLL proxying. So we need to change the execution afterwards, after we get this shell executed. Or we can try the process injection, which can help in that. So let's remove that. And don't tell me the message box was the problem. Crypt sp.dll. Let's host the shell. Let's run that again. Alright. Why? Why it works now? Never mind, but it does. Now what happens is that since we are creating new thread, pretty much, so what that thing is doing, it redirects the pointer to a stack we allocated the shellcode. So we create a file mapping object which can be used for sharing object in memory for different process. And then we use map view file to go there and do memcopy to allocate the shellcode into that file mapping. Right. Now what happens is that here we point integer pointer into the beginning of the stack and execute it at it is where a function, a regular function. So we parse the array into a function by pointing the pointer to the stack. Now that creates new thread and most likely alters the execution of the original program. Now in order to bypass that, it's gonna be a good idea to do process injection and DLL proxying, because since that DLL is not the original one, it's gonna fail. But before we do that, let me see what's happening under the hood. So we have the DLL DVTA, and keep in mind that we're using a reverse TCP, which was our initial huge IOC by spawning a command and so on. Now let's go to network and find the DVTA. Oh my god, that dog. And we can see the DVTA is connected to us, meaning that using DLL hijacking or DLL sidewalling eliminates a wall of IOCs, because imagine that's a real app that is, for instance, signed and is used and to perform internet connection, and if we hijack that and for instance, a boot teamer sees that, of course, I'm not a competent boot teamer and I'm not sure what else they can see. But for instance, they can see that. They can say, all right, that's DVTA, it's a nice program, it uses internet, it's connected to a HTTPS port. I think that's not a big deal. But like in the first example, when we have a CMD being spawned and then connects to us, like on that IP port, that's a huge IOC. Now, that by definition is explaining how... Oh my god, don't tell me you can't hear me on YouTube. Oh my god, don't tell me that's the case. Then connects... I can hear myself, so most likely it's on your side. If other guys are watching, please confirm you can hear me on YouTube. I'm so bad at this stream management stuff, but never mind. So appreciate your feedback, Desi. All the love. So that confirms that by using DLL and by using DLL hijacking as technique, we mitigate a lot of IOC that can be placed. Sweet. Now, I was expecting something like a subprocess of CMD, but it just spawned individual one. But if we connect a different C2 like Sliver, we should not see anything whatsoever. Why not test that? Why don't test that? Let's just do that. So I'm gonna close the DVTA. Or first let's do DLL proxying. We need to read a lot about that. I'm looking for that blog post right here from my team, which I'm a huge fan of. So let's see how that works. In the concept of malware, DLL proxying. Alright, is renamed. Alright, so a legitimate DLL, say legit.dll, is renamed to legit1.dll. And malicious DLL exports all the same functions that the legit1 exports is placed inside the legit DLL. Alright, so the legit1 is being the malware? No, the legit1 is being the legit. And the legit.dll is the malware. Yeah, it makes sense. Alright, so the legit.dll gets loaded into the carving process and executes its malicious code. Then forwards the code to export function 1. So that's a simulated stuff in environment. Do we have a way of seeing which functions we need to export? Oh yeah, so that blog post is explaining how to do that, but we need to find a way to export the function. So I think that should be too much for now. I'm gonna do my best to get more context of that and make a video or stream about it. Teams and Zoom are pretty good target for sideboarding. Indeed, yeah, indeed. So what I'm thinking now is I'm gonna pause the DLL proxying because I'm not really competent about that, and then I'm gonna make a video or stream about that after I read more and test, yeah, in different video stream. Yeah, never mind. So now let's test that with Sliver. I'm gonna do, or with Metasploit, because it did not work with Metasploit before. Let's do the very same interpreter staged one, and let's host the handler. Yay, cybersecurity India. Hi there. Thank you for watching. It's so good. We are doing DLL hijacking and stuff, testing C2s and see what IOC they can do. And I apologize because I started the YouTube stream way after the Twitch one, but the full video is gonna be uploaded there. So yeah. Now let's copy the shellcode again and edit the DLL file here. Oh my god, that dog didn't stop barking for the whole night. Never mind. Now do it like that, and now should be fine. Let's compile. Delete that and do crypt sp. Handler is ready, and bam, test sending stage. So it worked with stageless payload, but it's not working with staged payload. So we know that this thing was executed because we achieved the initial stage. Right, we have initial callback. But something is breaking when we try to download the shellcode, the stage shellcode, and then finish the execution. So I can say that is something with the stage that's not going all right. What we can do, by the way, is implement our own staging, which I think should be better. Now, again, I have a snippet for that. So it's on my offensive CPP directory and under Win API, and we have that Win HTTP. We have shellcode downloader. So that one here, we can just copy and paste that. That was the main idea of the repo. So I can do bam, just like that. And that thing is gonna download the shellcode. Sweet. Now, initially we can parse the IP and the port just like that. So I can do, I need to generate a new one. That one is gonna be stageless. The format's gonna be raw, and the output file is gonna be enc, or what was the file name? Yeah, enc.bin. enc.bin. And yeah, that should be fine. Now here I'm gonna do set payload to that. Show options. Looks nice. Exploit. Alright. Oh my god. Let me just close that. DVTA. Alright. Now, what we need to do is to modify the size. So we need to define an array. Like that. And increment it by 1. So if the bytes are like that many, 207.74, we need to do that 207.75. Now we have that DLL function which is gonna download the shellcode into that buffer variable. Alright. And from there we can do that, and that thing is gonna get populated. So we don't need that buffer anymore because we already have that. Alright, we don't need that main, but we need that. So I'm gonna cut and paste and delete, and that should be fine. Now, by definition, that downloader is, oh my god, such a mess. I have the windows.h, so I don't need that. Alright. So by definition, that downloader is using HTTPS connection. So for that purpose, I'm gonna need to do a very simple Python HTTPS server and host the files with that. So there was a snippet for that online, which we can easily find. So I can do Firefox here, then do Python HTTPS server. Yeah, there we are. Oh, it's not that. Python HTTPS. It's maybe that. Yeah, that's how we generate a certificate. So copy that, go to desktop, stream, and just paste the command. And do bam, 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 enter. And now I have server.pem. Let's leave it as it is. And then just copy that code here, which you see, and make a new Python file. So you can obviously do that as a one-liner, but to be honest, having script is always better. It's always snippets. So let's do vim and then server.py, set paste and paste that, and now just modify that to be 0000, meaning that's gonna listen on no interfaces, and the port is gonna be 8443. Now when we leave the file name as it is, server.pem is gonna search for the current directory, meaning that we should be fine. Alright, so Python 3 server.py. Oh my god. Yeah. Now we're talking. Oh. What you want now? It's Python 3, right? Yeah. What was the error, by the way? Name or service not known. What the fuck? Server address. Handler. Why? We have them. So it's on that line. On which SOC server TCP, so that one here. I mean, that is the same. Indeed the same. Oh my god, my bad. My bad. Yeah, you pointed it out, right? Yeah, thank you. Alright, so Python 3 server.py. Now we're talking. Alright. Now what that's gonna do is gonna pull the enc.bin from that file server, which is having an SL communication, and it's gonna populate that buffer variable, and then that thing is gonna get executed using the same file map syntax. Nice. So compile that. Oh, I did something bad again. Compile that. Alright, and again delete that and copy that here and do not that crypt sp.dll, and I'll make sure my handler is up and running. It is. So crossing fingers, running that. And something, oh, crypt, maybe we did crypt base, or what was the name? What was the DLL name? I mean, we had the message boxes, right? Oh, maybe the IP is wrong. Wait. My bad. 74134. Yeah, it's the same one. And 8443. Did I manage the port correctly? Yep, it is. So I can do... Come on. Yeah. I can query that, which is nice. But why didn't the application query that? I think it's better convention to have that here. Not sure why that's not executing. And why did we have a bunch of message boxes? So I'm gonna close that. I'm gonna do execute that again. Crypt sp, that should be it. And yeah, we have test and test again. So most likely it crashed in some form, because we saw that 2 times. I'm not sure what the hell is going on. Test 2. Test 2. Or do I need to include that into here? Maybe. Is that gonna make a difference? Maybe that's stupid, but sometimes things are happening by unexplained order. One, two, yeah, same thing. I can do one message box to debug that, so I can spam a message box, let's say here on causing the handles. Or maybe we should try and test if that's gonna work by using run DLL, right? That's gonna be the most obvious. Let's debug it from the war perspective and then move up. So here I'm gonna do that. Oh, yeah, we're doing something wrong there. Now we have something as an output, which I'm not sure why that is. If you guys have any idea, just feel free to notify me with that. So that's executed. We know for sure. Now what's gonna happen, by the way, if I do that? Nope. And that. Nope. I'm doing something super wrong with the DLL. Let me just see if that thing's gonna work if I do the exe version. So let's go back to the exe. Here. By the way, I can copy the whole snippet. Or not, never mind. Alright, so that's my DO function. That's my buffer there. And we need the imports. Just like that. Alright. Well, let's compile and test that. Or maybe we are doing something wrong with the shellcode execution, which should not be the case, but let's see that. Stream.txt. No request at all. Let me try another snippet. Maybe I did something wrong with that one. If I did something wrong, I'm gonna update that with my one. Nope, not that. It's not that. Copy. All right, that's it now. Now we don't need that, and that as well. And massive, by the way, is array in Bulgaria. Yeah, I make it massive just to be like don't have any signature. Yeah, I did not call the function in my Oh. Ah. I'm not gonna say anything here. Anything. Alright. Thank you so much, kind sir. Oh my god, thanks for pointing that out. Sometimes I'm getting so fucked out. So we know that works. We know that my snippet from the repository is working fine. Now let's find a way to make it work through DLL. What's missing here? Can we do it with run DLL, by the way? Let's try it again. Run DLL. Alright. And then my DLL main. So my DLL main, run that, closing handles. And we have a callback. So by exporting the main another function, it works. So most likely if we're gonna do DLL proxy and export specific function and chain that, it's gonna work. Yeah, it is now. But why it's not working if we do it on the DLL main? So I can again call it here. And do it like that. Compile. Oh yeah. Alright. Now let's try DLL main. Yeah. Let's see what that is. Dynamic link library initialization routine failed. Come on, give me quick answers. I'm doing 64 bits. It's not 32. That's super strange. Or maybe do not know where that API is. Can that be the case? Have that. Oh, wait. Have that. Let's try again. Did we get a callback after all, or nope? Hmm. Nope. Alright, let's see what we're getting wrong. So we have that function, which is nice. That function, we know it's working just fine, but something with the execution is doing something. And we know by excluding that, the DLL worked and we got a shell. So let's try to think about that. We're executing that from the DLL main DLL process attach. Then we have message box which executes, and we know that we get to here because that was executing as well. Or maybe, can we do it like that? Let's research more about what that is. I need to put the light on. Alright. Now it's better. Let's include C++. So we get that. If you guys can find an idea, just ping me up. So with that it works. So most likely something with the export. It has to be something with the export. Yeah. Because that it works. I mean, if we do my DLL main. Now you don't? Come on, what happened now? Oh, yeah. Yeah, we can see that it works now. So it's something with the function, something with the export. Can I run? What's gonna happen if I try to run that one from here? Most likely the same thing. Yeah. Yeah, that's not the same. Cannot just run functions like that. I'm thinking how we can bypass that and maybe call my DLL main somehow. Can we find what functions it requests? Not from the pros monitor. Because for instance when we do hijacking, the very same thing happens. So it tries to execute that from here, but by some meaning it's not working. Or can I try to search why that's not working? So we can do it like that and then like that. Oh, no, not like that. Like that. Yeah. So initialization routine failed. Alright, that's something close to us. Yeah, that's gonna be tougher as I thought. So, oh, sorry about that. So when we do, we need to most likely find now the function that the application requires. So by the way, let me just do something. I won't find the original DLL there. Delete that. Now do refresh. Yeah. And run that. By the way, I want to implement a new filter. So the path contains crypt sp at apply. So it tries to, oh wait. So it succeeded from Windows System 32 cryptsp.dll, and I'm sure that there can be a lot of functions there. So can you guys give me any kind of books or let's say references on how to get the functions from a DLL, or what functions does the file requires in order to wall something? I think that was explained in the Shit Secure's channel, by the way. Yeah, there we are. There we are. That's the one I was looking for. So we have a precompiled version, so I'm gonna copy that and just do new one, the right. So what that should do is it should scan the file and determine which of the DLLs can be hijacked and not. So I can do DLL hijack and then -F and then do DVTA execute bin release dvta.exe. Invalid execution mode specified. Alright, maybe mostly I'm doing something wrong with that. Let's see how it's getting executed. Alright, we need to do -mode -mode to be file scan. Enum dependency, we have the DLL hijack and the file. Do I miss something? Mode file scan, enum dependency, maybe let's try without it. That's super strange. Is it 32-bit binary, by the way? I mean, can this be? Oh, it was compiled as x64. I'm really not sure why that one is not working. Let's do -H. And let's do V3. Oh my god, that's way too much. Current API states him is 6. Could not find a match for API something. Could not validate PE. Oh, because it's an assembly. And Nero2K mentioned that there's a better tool for that. Spartacus, which I didn't really test that. So let's see how that works as well. But as I said, the issue is that it's an assembly, not a PE, not portable executable. Let's see if that was gonna handle that. We have the releases. Alright, download that. Extract to desktop, stream. Alright, do Spartacus. Now let's see the usage. --procmon. We specify. Oh, we specify the pros monitor. Alright. In my case, it's in C, then tools, then C's internals, then procmon64. Alright, that's one. Then CSV. Alright. CSV, then do output.csv. And then PML, I'm not sure what that is. Exports. And then here, verbose. PML is missing. What that PML is all about? Oh, so we need to parse. Yeah, the work date of the process monitor. All right. So what filter does it needs? In its operation is create file. So let's do operation is create file. Add patterns with DLL. So path ends with .dll. All right. I'm gonna get rid of that. Process name is not alright, so then process name is not procmon.exe. Add, and then it's not procmon64.exe. Add that as well. Then enable drop filter events to ensure minimum PML output size. Where is that? Not sure. Why? Alright. Disable auto scroll. No, it's not that. I think that should be fine, by the way. So let me just clear that and run the app again. Wait. Do I need to specify the exact file? In my case, that can be because we have a lot of files there. I didn't work with that before, so most likely we need to pass the process name to contain tvta. Clear? All right. Nope. All right. Oh, because I'm seeing that usage file here, and it's saying that I need to get a log file of procmon before that, or maybe I got it wrong. So on the usage, we see generate a PMC config file on the fly. Yeah. Or you're saying that it can generate it for me. Whoa. All right, let's do that. Procmon is that. Let's just close it. Then do PML test.pml. Oh my god. Now, should I need to run the app? I think I should. All right. That's overpowered, man. Whew. What I did now? Oh, so it found the crypt sp.dll. Nice. All right. We have the output file, so let's do Explorer here. Open that. Yeah, it found that DVTA. Oh my god, that's super overpowered, man. Nice, thank you for sharing. DVTA, all right. Missing DLL. Found DLL. Integrity. Bad system. And the command line. Alright, so let's see what else we got here. We have the Spartacus walk. All right, nice. Then what's that PMO about? Oh, we have a CPP file. Oh my god. It generates the function for us. Yep. All right. All right. So what do we do now? We have script-based DLL CPP. Oh, crypt SP. That's what we're trying to do. Alright, let's copy that into our code, which is here. Should it be after? Yeah, before. Whoa, it exported all the functions for that DLL. Nice. And what do we do now? Oh, it's just like that. So we can do... Oh my god. Let's keep the convention there. So we can do void exec. Alright. And it's used, yeah, it's the same thing, but now with the exported function. Don't tell me it's that easy. Oh my god. Alright, let's try that. Let's try that. So we have the message box, we have exec, and we break with the very same thing we have here. Alright, compile that, compile that. Now it's here. cryptsp.dll. Now let's make sure my listener is up and running. I, to be honest, do not expect it to work. So, but let's see. Run that. Yeah, I did not. Very same thing as before, or maybe I'm not doing something right. So in that case, we have cryptsp.dll, which exports all the DLL functions, right? What else should we do then? Based on a template, where I think we're doing the very same thing. I have all the exports here, I have all the includes here, I have function here, or maybe this should be defined before the main. In that case, that's the different part. Let's get rid of the message boxes, they don't really help. What I did now? Yeah, they don't really help, so I'm gonna remove that one as well. We know that thing is executing now. That should be fine. And I think we're doing more of the pain because we're doing initial staging. So that was not the problem in the first place. But you know, the more we know now. So it's void payload and something. And do we need to have the same syntax as that? Why not? So let's first try it without it, and then we can definitely compare it and change. So remove that, get the new one, paste here, cryptsp.dll, run that. Nope. Alright, in that case I'm gonna copy the main, by the way. Place it like that. And then do, what was that? Exec. We don't need that for now, so just to be sure I'm gonna comment that out. Copy that. And try again. Now I'm gonna save your time and explain what happened here. We pretty much tried multiple ways of executing our malicious function from DLL process attach function. We tried doing that by directly calling the function, using shellcode staging, which was not a logical thing to do, but we tried that. We used directly calling the function of directly writing the code into that DLL process attach, which was indeed incorrect way of doing that. The correct way was to actually use create remote thread API and from process attach just create a new thread pointing to the function we just wrote. So I have prepared a demo for you guys. Also, I'm gonna be doing a new video especially dedicated to that, so I'm gonna explain the process in a short time manner so you can enjoy. Yeah, thank you all for watching, thank you all for the support guys, thank you all for the tool sharing, and I'm gonna see you right in the next one.